All right, we found some more problems in Newton's unit, so there's a couple more things that we want to go over. Today we're going to look at what happens to the fuzzy dice in your car as you start to accelerate. If you've ever noticed your graduation tassel starting to move in a different direction than your car is moving, you've seen something like this before. We're going to calculate and put some numbers to these angles here. So let's start. Let's just assign this angle right here, this theta. So we're going to say theta is equal to 30 degrees. So what happens is the car is accelerating forward. If you're going at a constant speed, it's just going to hang straight down. But if you're accelerating forward or backward or any other way, you're going to see that start to sway. And we're going to say that the fuzzy dice has a mass equal to 1 kilogram. That'll be a nice, easy number to work with. So if this is our theta value, and that is our mass, we're going to solve for f sub t for this particular first problem. All right, first we want to draw a free body diagram. As always, there's the force of gravity coming down and just the force of tension coming up. So if we take these values from our free body diagram, the force of gravity is just equal to mg. We have 1 kilogram times 10 meters per second squared. So that's going to be 10 newtons. So now if I look at my triangle, since it's not accelerating in the y-plane, this force is equal to this component of tension. So I have this upward component of tension, which is 10 newtons. I have this value, which is due to my acceleration, and I'm looking to solve for the force of tension over here. If I know this angle is 30, I'm looking for the hypotenuse. I have an adjacent side, so I'm going to say cosine of theta is equal to the adjacent divided by my hypotenuse. Therefore, the hypotenuse is equal to the adjacent component, which is 10 newtons, divided by the cosine of 30 degrees, which is 0.86. So 10 divided by that value gives us a tension of 11.54 newtons. So based just upon the angle and the mass of the object, you can find the tension in the string of 11.54 newtons. Well, let's say we weren't given theta this time. Let's say we were given an acceleration. Same problem. The dice still weighs 1 kilogram, but now we are accelerating forward at 2 meters per second squared. And now we want to solve for theta. So if I go back and draw my same free body diagram, same forces, that's still going to be 10 newtons. So now, rather than have an angle, I have this component here based upon my 2 meters per second squared of acceleration. So how can I find that force value? Well, F is equal to ma. So the force there is equal to 2 meters per second squared of acceleration, and my mass of 1 kilogram. So it's just going to be 2 newtons. So here I'm starting to put together my triangle. This is still 10 newtons. This is going to be 2 newtons. And I'm looking for theta. So I have an opposite and an adjacent. So tangent equals opposite divided by the adjacent. So since I'm looking for an angle, I'm going to take the inverse tangent of 2 divided by 10. So I take the inverse tangent of 2 divided by 10, and I get a theta of 11.3 degrees. So 2 different ways to solve a similar problem. All right, and I think that should cover everything for Newton now.